Okay, so with urinary physiology, I know one of the trickier things to understand is what are we doing with GFR and why and when? And a lot of that has to do with the fact that, well, it depends on what blood pressure is doing. You actually have two negative feedback loops that you're trying to keep track of. One is kidney doing kidney things because blood's fine and we're just worried about ourselves. So it's the kidney trying to regulate glomerular filtration rate. Basically, they want to make sure they're doing their job at a consistent rate. Because glomerular filtration rate, for those who don't remember, is the rate at which we're getting that sample from our blood. When your blood pressure is outside of homeostatic range, then the kidney can't worry about itself. It has to help the cardiovascular system. So it's like, all right, never mind about maintaining consistent filtering rate. I care about helping with blood pressure. So it's two different answers depending on what you're up to. So let's help organize that. Let's first start with if you're in homeostatic range for blood pressure. In this case, your goal is maintain GFR. This is what I call kidney doing kidney things. Kidney cares about maintaining its filtering rate. That's why this is going to be under what we call autoregulation. It's kidney taking care of itself. We don't need to involve hormones. What's going to happen here, so let's say if you're in the normal range and you start filtering too much, and that happens when blood pressure just elevates a little bit, but it's still within the normal range. So we're filtering too much. So slight increase in blood pressure, still in range. That's going to cause an increase in GFR. What we want to do as a kidney is lower that GFR. So how do we do that? Well, the first thing we can do is just change how much we're letting in to make that sample. So what's going to happen is the afferent arteriole is going to stretch because of this increase in pressure. Remember, blood pressure is a hydrostatic pressure. It's a physical force. And so what's going to happen is, if you can kind of picture that vessel, it's built into the wall, if it starts to get stretched, it opens up these doors a little bit. Those doors let calcium into the muscle of that vessel. And so what's going to happen is it's going to let calcium in. And if you remember, calcium triggers a muscle contraction. So we're going to constrict the afferent arteriole, having less coming into the glomerulus, meaning less is available for making that sample. So that's your first step, is that you can constrict the afferent arteriole. This is muscle responding. So what we call that is the myogenic response. If that by itself isn't enough, then you can kick in step 2, the tubulo-glomerular feedback mechanism. What's happening here is when you get to the end, to the DCT, to the end of the nephron, you're going to notice, like, oh, we're filtering too much. There's too much in here. There's too much sodium and chloride. So we're going to send a signal back at the juxtaglomerular apparatus to say, yeah, too much is going on. Why don't we constrict the afferent arteriole more? But the other thing that we can do is we constrict the mesangial cells. Mesangial cells are the ones that are built into the loop. So we have the loops of the nephron built into the wall. And what we have inside of those loops are the cells, the mesangial cells. When they're relaxed, the loop stays nice and big, leaving the gaps between the podocytes, so the filtration slits, a little bit wider. But when we constrict the mesangial cells that are built in here, it tightens up the loop and it makes the space for things to flow through smaller, so you filter less. So that's what's happening with this one. So those are options if you are within normal blood pressure range. Kidney cares about this. But what if you're outside of normal? What if your blood pressure is out of homeostatic range? Well, now your goal, maintain blood pressure. GFR becomes a tool to do that. It's not the goal. So if your, for example, blood pressure is too high, how do we lower it? Well, we have to get rid of more fluid. We have to get more out of the containers. And the way we do that is filter more. So if blood pressure is too high, outside of homeostatic range, then now you want to fix it by increasing GFR. That's the opposite over here. Over here, blood pressure went up a little bit, still in the range, which increased your GFR. And then our goal over here was, well, let's lower it. But here it's too high. which means we are going to be filtering more. But we're going to say, no, let's filter even more. And we're going to send signals to say, do that. The signal to say we need to filter more is AMP. So that's our hormone. It tells us to do things like relax the mesangial cells, vasodilate, and inhibit renin, which is the hormone we'll talk about next when blood pressure is too low. It's the one that does the other job. So do the opposite of this, right? Which is weird, because here, too high, too high. The difference is in blood pressure homeostatic range, out of blood pressure homeostatic range. That's what you have to pay attention to. That's the hardest part, is knowing which question you're being asked, because the kidney will respond in opposite ways depending on what the goal is. If you're in normal blood pressure range, the goal is to keep filtering at the same rate. If you're outside of normal blood pressure range, then we have to filter to help modify that blood pressure. And in this case, just filter more so we can get that fluid out and help regulate blood pressure. Okay, so I did hint at renin, so we should talk about this. So what if blood pressure is too low? Well, if blood pressure is too low, well, we want to keep stuff. We don't want to filter as much. So if blood pressure is too low, then we want to lower GFR. So I guess I should say this is the goal, our tool that we're going to use. So this is the tool we're using, lower GFR. How do we do that? Well, we just talked about we're going to use renin. What renin does is it takes and converts angiotensinogen and converts it to angiotensin 1. And then we send it up to the lungs for angiotensin converting enzyme, or ACE, to get it to angiotensin 2. Once we have that, we can do things like activate thirst. So it's a center up in the hypothalamus. We'll release ADH, which is a signal to the kidneys to say we need to reabsorb water. So we insert aquaporins, or holes for water. We'll release aldosterone from the adrenal gland, which says bring in more salt. Why is that helpful? Waterfall of salt. If we bring in more salt, then we create an osmotic gradient. We're going to draw water back in. We will also vasoconstrict and contract the mesangial cells. So hopefully that helps to see them side by side of when you want to do things for GFR versus when you want to use GFR to do things for the blood. Thanks for watching.